A time zone is a region that observes a uniform standard time for legal, commercial, and social purposes. Time zones tend to follow the boundaries of countries and their subdivisions because it is convenient for areas in close commercial or other communication to keep the same time. Most of the time zones on land are offset from coordinated universal time by a whole number of hours, but a few are offset by 30 or 45 minutes. Some higher latitude countries use daylight saving time for part of the year, typically by changing clocks by an hour. Many land time zones are skewed toward the west of the corresponding nautical time zones. This also creates a permanent daylight saving time effect. History. Early timekeeping. Before clocks were first invented, it was common practice to mark the time of day with apparent solar time, for example, the time on a sundial, which was typically different for every settlement. When well-regulated mechanical clocks became widespread in the early 19th century, each city began to use some local mean solar time. Apparent and mean solar time can differ by up to around 15 minutes due to the non-circular shape of the Earth's orbit around the Sun and the tilt of the Earth's axis. Mean solar time has days of equal length, and the difference between the two averages to zero after a year. Greenwich Mean Time was established in 1675 when the Royal Observatory was built as an aid to mariners to determine longitude at sea, providing a standard reference time when each city in England kept of different local time. Railway time. Local solar time became increasingly awkward as rail transport and telecommunications improved, because clocks differed between places by an amount corresponding to the difference in their geographical longitude, which varied by 4 minutes of time for every degree of longitude. For example, Bristol is about 2.5 degrees west of Greenwich, so when it is solar noon in Bristol, it is about 10 minutes past solar noon in London. The use of time zones accumulates these differences into longer units, usually hours, so that nearby locales can share a common standard for timekeeping. The first adoption of a standard time was on December 1, 1847, in Great Britain by railway companies using GMT kept by portable chronometers. The first of these companies to adopt standard time was the Great Western Railway in November 1840. This quickly became known as railway time. About August 23, 1852, time signals were first transmitted by telegraph from the Royal Observatory, Greenwich. Even though 98% of Great Britain's public clocks were using GMT by 1855, it was not made Britain's legal time until August 2, 1880. Some old British clocks from this period have 2-minute hands, one for the local time, one for GMT. The improvement in worldwide communication further increased the need for interacting parties to communicate mutually comprehensible time references to one another. The problem of differing local times could be solved across larger areas by synchronizing clocks worldwide. But in many places that adopted time would then differ markedly from the solar time to which people were accustomed. On November 2, 1868, the then British colony of New Zealand officially adopted a standard time to be observed throughout the colony, and was perhaps the first country to do so. It was based on the longitude 172 degrees 30 east of Greenwich, that is 11 hours 30 minutes ahead of GMT. This standard was known as New Zealand Mean Time. Timekeeping on the American railroads in the mid-19th century was somewhat confused. Each railroad used its own standard time, usually based on the local time of its headquarters or most important terminus, and the railroad's train schedules were published using its own time. Some junctions served by several railroads had a clock for each railroad, each showing a different time. Charles F. Dowd proposed a system of 1-hour standard time zones for American railroads about 1863, although he published nothing on the matter at that time and did not consult railroad officials until 1869. In 1870 he proposed 4 ideal time zones, the first centered on Washington, D.C., but by 1872 the first was centered on the meridian 75 degrees west of Greenwich, with geographic borders. Dowd's system was never accepted by American railroads. Instead, U.S. and Canadian railroads implemented a version proposed by William F. Allen, the editor of the Traveler's Official Railway Guide. The borders of its time zones ran through railroad stations, often in major cities. For example, the border between its eastern and central time zones ran through Detroit, Buffalo, Pittsburgh, Atlanta, and Charleston. It was inaugurated on Sunday, November 18, 1883, also called the Day of Two Noons. When each railroad station clock was reset as standard time, noon was reached within each time zone. The zones were named Intercolonial, Eastern, Central, Mountain, and Pacific. Within a year, 85% of all cities with populations over 10,000, about 200 cities, were using standard time. A notable exception was Detroit, which kept local time until 1900, then tried Central Standard Time, Local Mean Time, and Eastern Standard Time before a May 1915 ordinance, settled on Est and was ratified by popular vote in August 1916. The confusion of times came to an end when Standard Zone time was formally adopted by the U.S. Congress in the Standard Time Act of March 19, 1918. Worldwide time zones. Although the first person to propose a worldwide system of time zones was Italian mathematician Quirico Filippanti in his book, Miranda, published in 1858, his idea was unknown outside the pages of his book until long after his death. So it did not influence the adoption of time zones during the 19th century. He proposed 24-hourly time zones, which he called longitudinal days, the first centered on the meridian of Rome. He also proposed a universal time to be used in astronomy and telegraphy. Scottish-born Canadian So Sandford Fleming proposed a worldwide system of time zones in 1879. He advocated his system at several international conferences, and is thus credited with the instigation of the initial effort that led to the adoption of the present time meridians, in 1876. His first proposal was for a global 24-hour clock, conceptually located at the center of the Earth and not linked to any surface meridian. In 1879 he specified that his universal day would begin at the anti-meridian of Greenwich, while conceding that hourly time zones might have some limited local use. He also proposed his system at the International Meridian Conference in October 1884, but it did not adopt his time zones because they were not within its purview. The conference did adopt a universal day of 24 hours beginning at Greenwich midnight, but specified that it shall not interfere with the use of local or standard time where desirable. By about 1900, almost all time on Earth was in the form of standard time zones, only some of which used an hourly offset from GMT. Many applied the time at a local astronomical observatory to an entire country, without any reference to GMT. It took many decades before all time on Earth was in the form of time zones referred to some standard offset from GMT, UTC. By 1929, most major countries had adopted hourly time zones. Nepal was the last country to adopt a standard offset, shifting slightly to UTC plus 545 in 1986. Today, all nations use standard time zones for secular purposes, but they do not all apply the concept as originally conceived. North Korea, Newfoundland, India, Iran, Afghanistan, Venezuela, Burma, Sri Lanka, the Marquesas, as well as parts of Australia use half-hour deviations from standard time, and some nations, such as Nepal, and some provinces, such as the Chatham Islands, use quarter-hour deviations. Some countries, most notably China and India, use a single time zone, even though the extent of their territory far exceeds 15 degrees of longitude. Before 1949, China used 5 time zones. Definition: Until 1972, all time zones were specified as an offset from Greenwich Mean Time, which was the mean solar time at the meridian passing through the Royal Observatory in Greenwich, London. Since 1972, all official time services have broadcast radio time signals synchronized to UTC, a form of atomic time that includes leap seconds to keep it within 0.9 seconds of this former GMT, now called UT1. UTC, also called Zulu time, is used everywhere on Earth by astronomers and others who need to state the time of an event unambiguously. Time zones are based on Greenwich Mean Time, the mean solar time at longitude 0 degrees. The time derived from atomic clocks is adjusted because the rate of rotation of the Earth is not constant. In January 1972, Coordinated Universal Time was introduced with the length of the second equal to the second of atomic time. The readings of atomic clocks are averaged to give a uniform time scale. Because the length of the average day is currently 0.002 seconds more than 24 hours of atomic time, leap seconds are periodically inserted into Coordinated Universal Time to make it approximate to UT1. Because the Earth's rotation is gradually slowing, leap seconds will need to be added more frequently in the future. However, from one year to the next the rotation rate is slightly irregular, so leap seconds are not added unless observations of Earth's rotation show that one is needed. In this way, local times will continue to stay close to mean solar time and the effects of variations in Earth's rotation rate will be confined to simple step changes relative to the uniform time scale. All local times differ from TI by an integral number of seconds. With the implementation of UTC, nations began to use it in the definition of their time zones. As of 2005, most nations had altered the definition of local time in this way. British Summer Time is still 1 hour in advance of Greenwich Mean Time and is therefore approximately equal to UTC plus 1. Thus Greenwich Mean Time is the local time at the Royal Observatory, Greenwich, between 100 GMT on the last Sunday in October and 100 GMT on the last Sunday in March. Similar circumstances apply in many other places. Leap seconds are considered by many to be a nuisance, and ways to abolish them are being considered. This means letting the time difference accumulate. One suggestion is to insert earthly power in about 5,000 years. Notation of time. ISO 8601 UTC. If the time is in Coordinated Universal Time, add a Z directly after the time without a space. Z is the zone designator for the 0 UTC offset. 930 UTC is therefore represented as 930Z or 0930Z. 14 hours 45 minutes and 15 seconds UTC would be 14 hours 45 minutes and 15 seconds Z or 144515Z. UTC time is also known as Zulu time, since Zulu is the ICAO-speaking alphabet code word for Z. Offsets from UTC are written in the format plus or minus HH/mm, plus or minus HH/mm, or plus or minus HH, ahead or behind UTC. So if the time being described is 1 hour ahead of UTC, the zone designator would be plus 100, plus 0100, or simply plus 01. This is appended to the time in the same way that Z was above. The offset from UTC changes with daylight saving time, e.g., a time offset in Chicago, which is in the North American Central Time Zone, would be -600 for the winter and -500 for the summer. Abbreviations. Time zones are often represented by abbreviations such as SWST, CST, but these are not part of the International Time and Date Standard ISO 8601, and their use as sole designator for a time zone is not recommended. Such designations can be ambiguous. For example, ECT could be interpreted as Eastern Caribbean Time, Ecuador Time, or European Central Time. Time zones and time offsets. A time zone is a geographical region where almost everyone observes the same standard time. A time offset is an amount of time subtracted from or added to UTC to get the current civil time, whether it's standard time or daylight saving time. In any particular time zone, a resident either observes standard time all year round, or observes standard time in winter and daylight time in summer. UTC offsets worldwide. List of UTC offsets. These examples give the local time at various locations around the world when daylight saving time is not in effect, where the adjustment for time zones results in a time at the other side of midnight from UTC. Then the date at the location is 1 day later or earlier. Some examples when UTC is 2300 on Monday when or where daylight saving time is not in effect. Cairo, Egypt. UTC plus 02, 100 on Tuesday. Wellington, New Zealand. UTC plus 12, 1100 on Tuesday. Some examples when UTC is 200 on Tuesday when or where daylight saving time is not in effect. Honolulu, Hawaii, United States. UTC minus 10, 1600 on Monday. Toronto, Ontario, Canada. UTC minus 05, 2100 on Monday. The time zone adjustment for a specific location may vary because of daylight saving time. For example, New Zealand, which is usually UTC plus 12, observes a 1-hour daylight saving time adjustment during the Southern Hemisphere summer, resulting in a local time of UTC plus 13. Time zone conversions. Conversion between time zones obeys the relationship time in Zone A minus UTC offset for Zone A equals time in Zone B minus UTC offset for Zone B, in which each side of the equation is equivalent to UTC. The conversion equation can be rearranged to time in Zone B equals time in Zone A minus UTC offset for Zone A plus UTC offset for Zone B. For example, what time is it in Los Angeles when the New York Stock Exchange opens at 9:30? Time in Los Angeles equals 9:30 minus plus equals 6:30. In Delhi, the New York Stock Exchange opens at time in Delhi equals 9:30 minus plus equals 2000. These calculations become more complicated near a daylight saving boundary. The table, Time of Day by Zone, gives an overview on the time relations between different zones. Nautical time zones. Since the 1920s, a nautical standard time system has been in operation for ships on the high seas. Nautical time zones are an ideal form of the terrestrial time zone system. Under the system, a time change of 1 hour is required for each change of longitude by 15 degrees. The 15 degrees gore that is offset from GMT or UT1 by 12 hours is bisected by the nautical dateline into two 7.5 degrees gores that differ from GMT by plus or minus 12 hours. A nautical dateline is implied but not explicitly drawn on time zone maps. It follows the 180th meridian except where it is interrupted by territorial waters adjacent to land, forming gaps. It is a pole-to-pole dashed line. A ship within the territorial waters of any nation would use that nation's standard time, but would revert to nautical standard time upon leaving its territorial waters. The captain is permitted to change the ship's clocks at a time of the captain's choice following the ship's entry into another time zone. The captain often chooses midnight. Ships going in shuttle traffic over a time zone border often keep the same time zone all the time, to avoid confusion about work, meal, and shop opening hours. Still, the timetable for port calls must follow the land time zone. Skewing of zones. Ideal time zones, such as nautical time zones, are based on the mean solar time of a particular meridian located in the middle of that zone, with boundaries located 7.5 degrees east and west of the meridian. In practice, zone boundaries are often drawn much farther to the west, with often irregular boundaries, and some locations base their time on meridians located far to the east. For example, even though the prime meridian passes through Spain and France, they use the mean solar time of 15 degrees east rather than 0 degrees. France previously used GMT, but was switched to CET during the German occupation of the country during World War II and did not switch back after the war. Similarly, prior to World War II, the Netherlands observed Amsterdam time, which was 20 minutes ahead of Greenwich Mean Time. They were obliged to follow German time during the war, and kept it thereafter. In the mid-1970s, the Netherlands, as with other European states, began observing daylight saving time. There is a tendency to draw time zone boundaries far to the west of their meridians. The main reason for this is that similar working day schedules around the world have led to people rising on average at 700 clock time and going to bed at 2300 clock time. This means that the middle of the period that people are awake occurs at 1500 clock time, whereas, if using as clock time the time of the nautical time zone to which the location concerned geographically belongs, solar noon occurs at 1200 clock time. To make solar noon coincide more with awake time noon, the time of one or even two nautical time zones to the east is chosen. Many of these locations also use DST, adding yet another nautical time zone to the east. As a result, in summer, solar noon in the Spanish town of Muxia occurs at 1437 clock time, indeed very close to awake time noon. This westernmost area of continental Spain never experiences sunset before 1800 clock time, even in midwinter, despite its lying more than 40 degrees north of the equator. Near the summer solstice, Muxia has sunset times similar to those of Stockholm, which is in the same time zone and 16 degrees further north. Stockholm has much earlier sunrises, though. A more extreme example is Nome, Alaska, which is at 165 degrees 24 W longitude, just west of center of the idealized Samoa time zone. Nevertheless, Nome observes Alaska time with DST, so it is slightly more than 2 hours ahead of the sun in winter and over 3 in summer. Kotzebue, Alaska, also near the same meridian but north of the Arctic Circle, has an annual event on the 9th of August to celebrate two sunsets in the same 24-hour day, one shortly after midnight at the start of the day, and the other shortly before midnight at the end of the day. Also, China extends as far west as 73 degrees 34 E, but all parts of it use UTC plus 800. So solar noon can occur as late as 1500 in western portions of China such as Xinjiang and Tibet.